this video we're going to be looking at parallelism in vectors, and two vectors are parallel if they're a multiple of one another. So here we have an example. It's 2 minus 1r, and it's supposed to be parallel to s2 and minus 3. So the question you might ask yourself is, when I do the second vector that's something times the first vector, how do I get from minus 1 up to 2? Well, I times by minus 2. So 2 times by minus 2 would give me s. That would mean 2 times minus 2 is s, so s is minus 4 in that case. R times by minus 2 would give me minus 3. R times minus 2 equals minus 3. Therefore, R is minus 3 over minus 2. R is 1.5. So that's how that sort of works there. You can sort of imagine the vector here, this first one is like half of the second one. Next, we want to find a vector b length of 7 units in the opposite direction to a. So the first step here is going to be to find this very special vector called a hat. And the formula for that is 1 over mod a times a. And that'll give us a vector which has a length of 1, but pointing in the same direction as a. So that's going to be 1 over square root of 2 squared plus minus 1 squared plus 1 squared times 2 minus 1, 1. So that's going to be 1 over root of 6, 2 minus 1, 1. And that's sort of our a hat vector. So essentially, if you want to step it out and say exactly what it is, this is going to be 2 over root 6, minus 1 over root 6, and then 1 over root 6. That's our vector a hat. Now, b is not the same as this. B is supposed to be, well, it's sort of negative in the direction of a hat. Now, that would give us a vector that has a length of 1 pointing the other way from a hat. And we also then need to scale that vector up by 7. So that's the vector we're looking for. So this is minus 7, lots of 2 over root 6, minus 1 over root 6, 1 over root 6. That's going to give us all minus 14 over root 6, then positive 7 over root 6, then minus 7 over root 6. And that's sort of the vector that we're looking at there. Cool. So next we're going to prove these three are collinear. So what we're expecting, and what the word collinear means, is that they're all on the same line. So A, B, C, we should be able to draw a straight line through them. Now the way that we do that is we look at this vector A to B, and it should be parallel to the vector B to C. And then if they're parallel and they also share the point B, that's going to do our proof for us here. So the vector AB is going to be, how do I get from minus 1 to 4? Well, I go up by 5. 2 to 0 is minus 2, and 3 to minus 1 is minus 4. And then BC is going to be, well, 4 down up to 14 is 10. 0 down to minus 4 is minus 4. Minus 1 down to minus 9 is minus 8. And therefore, BC, I think we can agree, is 2 times AB. You can see everything you double as you go down from AB to BC. Therefore, BC is parallel to AB. Those two vectors are parallel. And also B is a common point. Therefore, A, B, and C are collinear. It means they lie on the same line. So you could have had this thing like AB and BC being parallel, and that's sort of like B and C and A. And that wouldn't really prove they're collinear because they're parallel, but they're on different lines. But the fact that these 2 points are both B, which means they're the same point, means that it has to look more like that, which means that they are collinear. It's a bit weird, but if you ever have trouble with it, just remember to prove they're collinear, you want to prove that AB is parallel to BC. There's a few ways to do it. You could prove that AB is parallel to AC as well. That would also work, or any combination really, as long as you've got all 3 points sort of in there.